talk about the equator. The equator of watermelon is an imaginary line that divides into equal halves, running perpendicular to the axis of rotation. It is the largest circumference and represents the widest part of spherical shape. Next is the pole. The pole of watermelon are the 2 points on the surface of watermelon that lie at the ends of the axis of rotation. They represent the highest and lowest point on the spherical surface. The poles are the points where the axis of rotation intersects the surface of watermelon. The equators and poles are important geometric figures that help define the overall spherical shape and symmetry of watermelon. These points of reference are crucial for understanding the watermelon orientation, rotation, and overall geometry.
What is a great circle? A great circle is the largest circle that can be drawn on a watermelon, and it divides into 2 equal halves. A great circle has a finite length. As you can see, that the circle goes all the way around the watermelon, but it stops where it started. And lastly, the circumference of a circle is 2 pi r.
You might be wondering what the watermelon has to do with an arc circle. As we all know, the watermelon is a three-dimensional object with a curved surface. This curved surface is a reminiscent of an arc, which is a portion of the circumference of a circle. This arc circle concept is fundamental in geometry, as it helps us understand the relationship between circles, angles, and arcs.
You might be wondering what this watermelon has something to do with geometry. So imagine that this watermelon is a representation of a diamond. So a diamond is a 2-dimensional shape with just 2 sides. So we can think of it, this curve as a surface of the watermelon. So this curve represents the 2 sides of a diamond, and these are the 2 points.
In elliptic geometry, triangles are defined on the surface of this watermelon or sphere. The vertex is located either at the top of the watermelon or at the bottom. The vertex is obtuse because the sides of the triangle, these two, converge as they approach the pole. The convergence causes the angle at the pole to be greater than 90 degrees, thus making it obtuse.
What is a separate quadrilateral? The line joining the midpoint of the base and the summit of the separate quadrilateral is perpendicular to both the base and the summit. The angles are congruent and obtuse. The sum of the measures of the angles of any quadrilateral is greater than 2 pi radian or 360 degrees.
So finally, we have Lambert's quadrilateral.
Since these 2 angles have been proven obtuse in our Zachary quadrilateral, we must now locate the midpoint of this arc and this arc. By locating the midpoints, we can then connect them, thus creating another line which is perpendicular to this arc and also to this arc. Since this line is perpendicular to this arc and also to this arc, we can now have 3 right angles. So therefore, in our Lambert's quadrilateral, in elliptic geometry, we have 3 vertices as right angles and 1 vertex as an obtuse angle.
Now we have learned the different concept of elliptic geometry using
The watermelon as our model of the sphere. Its parts namely are
diagon, great circle, poles, and equator.
the arc of the circle, the triangle, Zachary quadrilateral, and the Lambert's quadrilateral.
I hope you learned something today. Thank you for watching.
See you next time. Bye.